Did you know that the surface of the moon smells like gunpowder, just like the center of our galaxy? A cloud rich in billions of cubic meters of alcohol, in which there are molecules that contribute to the aroma of raspberries and the smell of rum. And that the inside of Jupiter has a scent of bitter almond. In short, as you can see, today we're going to stick our noses into a lot of places where it's better not to. By that I mean deep space, like the surface of other planets. Well, I imagine that kind of statement must definitely sound strange to you. How is it possible to know the smells of celestial bodies so far away, places we've never set foot in? Let me explain, you'll see, it's fascinating. To know the fumes of Jupiter's atmosphere, like those of distant interstellar clouds, you simply have to observe them. You have to understand that, in nature, when atoms or molecules are agitated, they emit particular wavelengths. Now, we have discovered that each element, whether atom or molecule, has a unique and singular spectral signature, in a way, a luminous fingerprint that allows us to identify it. From then on, as soon as a star emits or reflects light, it becomes possible to know from a distance what it is made of. For that, we simply need to look at it and analyze the types of radiation coming from it. In other words, through light, we can reconstruct the olfactory identity cards of what we are looking at. That being said, you can now close your eyes and open your nostrils wide. Here you are now on the surface of Mars, whose atmosphere is rich in things to breathe. And yet, the scent of the arid landscapes of the red planet must be, olfactorily speaking, quite disappointing. Because almost all of the elements present in the atmosphere of Mars would have no smell for us. In reality, for us to be able to smell a molecule passing through our nostrils, we need to have receptors capable of detecting its presence. Consider that, on Earth, none of the 8 main components of air are perceptible to us. You can see its composition currently displayed on the screen. None of these molecules are detectable by our nose. In fact, if what we breathe in sometimes has a smell, it's mostly due to complex volatile compounds found in the air, which are largely produced by living organisms or by suspended minerals. So, taking off your suit to take a big breath of Martian air, at most, you would only notice a whiff of dust and rusty rocks, accompanying the odorless scent of death. Because exposing your body directly to a pressure 170 times lower than on Earth would immediately cause your bodily fluids, such as the mucous membranes in your lungs, saliva, or tears, to boil. That's why, before we continue our olfactory odyssey, let's clarify that when we talk about the smell of these celestial bodies, it's not the one you would experience if you stepped out of a spaceship without a proper suit. On the infernal Venus, for example, the 460 degrees on the surface wouldn't even give you time to smell the olfactory characteristics of the planet's atmosphere. And the only thing you would smell here would be burning, before dying, cooked on the spot. To fully enjoy the scents of these worlds safely, you would actually need to take a small sample of their atmosphere, and then test it well protected from the conditions that prevail there. So, even though the crushing atmosphere of Venus contains 96.5% carbon dioxide, a molecule that has no scent, for us, the large amount of sulfur compounds found there should satisfy fans of seriously strong smells. To put it simply, the planet of the goddess of love must, at least in part, strongly smell like rotten eggs on the surface. Meanwhile, at higher altitudes, the clouds of pure sulfuric acid, which are highly corrosive, must react strongly with other suspended substances, giving off a scent that vaguely recalls the powerful smell of harsh acidic volcanic fumes mixed with extremely irritating and aggressive vinegar for an olfactory experience that is slightly less violent and, above all, radically different. Now let's go smell the gas giants, Jupiter, Saturn, Uranus, or Neptune. If you were to stick your nose inside these planets, which have no solid surface, you would notice the smells changing slightly as you go deeper. Because even though these planets are mostly made up of odorless elements, such as dihydrogen, helium, or methane, there are also plenty of elements with very distinct olfactory characteristics. There are slight differences between the 4 gas giants. In the upper atmosphere of Jupiter, there are traces of ammonia, which must give the giant a slight smell of litter box. To put it bluntly, it smells like pee here. And as you go deeper into this star, with the density of the atmosphere constantly increasing, the smell would become more and more present and intense, reminding you, with a burning and suffocating sensation, of powerful industrial solvents. And these acrid and aggressive smells would soon be accompanied by the aroma of rotten eggs, caused by the presence there as well of hydrogen sulfide inside Jupiter's thick clouds. We have also been able to detect the presence of hydrogen cyanide, whose strangely pleasant smell has the gentle lightness of bitter almonds. But this subtlety hides a terrible secret, that of the toxic nature of a compound that not everyone is able to identify. Because, just like the very particular smell that urine gives off after you've eaten asparagus, the ability to smell hydrogen cyanide is written in our genes and is not present in the entire population. The good news, however, is that prolonged exposure to this substance has the strange effect of making you lose all sense of smell. A major advantage is knowing that as you descend deeper into the gas giant's turbulent atmosphere, it eventually resembles the breath of foul-smelling demons. Phosphine hydride molecules, whose persistent smell is often compared to that of garlic or rotten fish, start to appear. We are now facing Titan, the largest of Saturn's moons, a celestial body 10 times farther from the Sun than our planet, and which, from an olfactory point of view, must be very interesting, because here, within the dense atmosphere of this satellite, in addition to odorless gases such as nitrogen and methane, we also find large quantities of ethane, as well as volatile aromatic compounds like benzene, a chemical substance whose smell is similar to petroleum. In other words, the surface of Titan, with its 180 degrees C temperature and its gigantic hydrocarbon lakes, must basically smell like a gas station. But without the smell of tires, asphalt, and metals. In the icy atmosphere of this moon, complex and acrid hydrocarbons swirl, along with volatile ethane, which adds a slightly ethereal touch to the melodic fumes of gasoline, the industrial aromas, and the scent of petrochemical refineries. Now let's leave this fascinating environment to go bury our noses in the imposing coma of the comet. 67 P. Churyumov-Gerasimenko, here. In 2014, the Rosetta probe crossed the immense trail that forms in the direction opposite to the Sun, and using one of its instruments, it directly analyzed the compounds. Within this comet's tail, scientists were able to identify, mixed in with a large number of odorless molecules of vapor, water, carbon dioxide and carbon monoxide, sulfur, hydrogen and ammonia. We have already experienced the overwhelming smell of solvents and rotten eggs, as well as formaldehydes, whose sharp, almost aggressive scent is reminiscent of the sting of certain disinfectants found in sterile or medical environments. In other words, the beauty of comet tails is almost certainly inversely proportional to the delicacy of their fumes, because they smell a bit like urine, rotten eggs, and hospitals. This rather harsh olfactory identity is slightly softened by the presence of traces of cyanide and hydrogen in the tail, the sweet and deceptive scent of bitter almond, but also of vinegar and carbon disulfide, a chemical compound whose pleasant aroma, similar to nail polish remover, actually hides a powerful toxicity. The striking beauty of this image shows us the remains of a star that has now disappeared. But by studying the nature of light, it also gives us access to one of the most bewildering olfactory experiences there is. Because in these nebulae lies the scent of the death of stars, in these drifting clouds of gas produced during the final moments of dying stars, we find large quantities of complex organic molecules, such as polycyclic aromatic hydrocarbons. A name that probably doesn't mean much to you, yet you encounter these kinds of molecules every day, because they are produced by incomplete combustion processes, so much so that we find them on Earth in the smell of tar or burnt toast. Elsewhere in the universe, these polycyclic aromatic hydrocarbons are found in the expanding gas envelopes surrounding dying stars, just like in the dense and cold molecular clouds, which probably smell very faintly of something burnt, like a poorly adjusted barbecue or burnt charcoal. To end on a slightly fruitier note, let's take a closer look. This is Cytarius B2, a drifting molecular cloud located near the galactic center, 25,000 light-years from Earth. Within this vast collection of dust and gas, spanning more than 100 light-years, scientists have identified the presence of dozens of different odorant molecules, including ethyl formate, a unique compound that contributes to the flavor of raspberries and the sweet, smooth scent of rum, and is regularly used in perfumery. If you ask where to open the last bar before the world's end, well, you should know that it's most certainly in a molecular cloud of this type, because there you can find 10 million billion liters of drifting alcohol. And let's clarify that even though it's tempting to imagine these molecular clouds literally soaked with sweet and sour notes, spirits, and fermented fruits, the reality is much more complex. Because these clouds are made up of a myriad of other chemical compounds whose smells are probably altered by the extreme temperature and pressure conditions that exist in space. And above all, these notes of alcohol and fruit would be impossible to catch, since the concentration of molecules in these clouds is far too low for a human nose to detect them. Researchers even had fun calculating how big our nose would have to be to detect the fragrances of the molecules we've talked about. They inevitably end up with a nose several kilometers wide. Strangely, while these scents would need to be about 10,000 times more concentrated for humans to appreciate them, other animals could probably pick them up easily. Consider that our species only has 5 to 10 million neurons specialized in detecting odors, whereas rabbits have nearly 100 million of these neurons, and dogs have around 220 million. In fact, it is estimated that dogs can generally smell with an intensity and precision 10,000 to 100,000 times greater than ours. And in some cases, they can detect molecules a billion times more diluted than the detection threshold of our own sense of smell. To the point where a trained dog is able, with training, to distinguish by smell between cancerous cells and healthy cells, or even between two identical twins who have the same genetic makeup. Pigs, on the other hand, can smell truffles buried under 20 centimeters of soil, while salmon are apparently able to taste the chemicals dissolved in the water. This helps them find the river where they were born, by tracking these olfactory characteristics diluted in the ocean until they trace it back to its source, closer to us, and without needing to analyze the light spectra coming from distant objects. Some Earthlings have had the unique experience of inhaling the sense of space, or more precisely, of objects that have been in prolonged contact with its near vacuum. These are the astronauts, and I think it's time to talk about the smell of the moon during the various Apollo missions that landed on our satellite. After each return to the lunar module, the astronauts almost always reported smelling a very particular odor, that of gunpowder. It is believed that this rather incongruous smell came from lunar dust, a dust as fine as the ash from our fireplaces. It tended to cover the equipment and stick everywhere on the suits, and so, after each outing, it was invariably brought back into the cabin in large amounts. Even today, the origin of this surprising smell is not fully understood. Because on the surface of the moon, the dusty soil, called regolith, is mainly made up of tiny crystals of dioxide, silicon, as well as a bit of iron, calcium, and magnesium. All these efforts and elements, as you may have noticed, don't have much to do with gunpowder. As it stands, we think that this smell most likely comes from the formation of new chemical compounds. When this lunar dust ends up in the astronaut's cabin, in the presence of oxygen and a bit of humidity, unless it comes from ions, carried by the solar winds, which, after sticking to the suits, combine with the air in the module to form new molecules. We don't know exactly. The mystery remains unsolved, even closer to our planet. Many astronauts who have done a spacewalk from the International Space Station mention having smelled something once they removed their suit. The persistent presence of a diffuse smell, of grilled meat or, for some, overbaked cookies, accompanied by an aroma similar to that coming from coins. In any case, all astronauts agree that these slightly metallic odors appear in the International Space Station only after their extravehicular activity, as if those who went for a little walk outside had brought back with them, inside the spacecraft, the lingering olfactory traces of space. Of course, the vacuum itself has no smell, but the few ionized particles present around the station can cling to the spacesuits. Then, once inside the spacecraft, they react with other elements in its atmosphere. In any case, if someone had to create a perfume inspired by the scents inside orbital stations, no one would wear it. Because according to those who have experienced these enclosed spaces, it would be nothing but a persistent mix of stale sweat, solvent, and fuel. So, when the astronauts return to Earth and the ground support team opens the capsule, they often recoil after spending several months locked up in space, where the air circulates in a closed loop. I think it's fair to say that it smells stuffy and like a very concentrated human elixir. Well, if the idea that smelling means coming into contact with volatile molecules on a microscopic scale bothers you, you can always reassure yourself by remembering that, unlike those in your brain, your olfactory and taste neurons are constantly renewing themselves. And they have an average lifespan of about 28 days, which means that every month you kind of have a newborn. Before watching this video, you could probably easily identify, with your eyes closed, the smell of a pine forest, a new car, a shoe store, a perfume shop or a bakery, the scent of your loved one, your attic, rain on hot asphalt, a wet dog, snow, or a library. and now even that of other planets. And one last thing, you don't have to be a genius to realize that, at first glance, this video contains way too much information to digest. To remember each of them, however, there is a method that can make memorizing them a bit easier. Because if this video made you feel some emotions, then associating it with a remarkable smell might one day help you bring back to the surface of your mind the memory of this story and what you, hopefully, learned from it. Because research has shown that the sense of smell is by far the most deeply rooted in our memories. Have you ever walked down the street? When suddenly, like an unexpected flower pot falling on your head, a distant memory comes back to you, thanks to a smell or a perfume worn by a complete stranger. Let me know if it works. And if you sensed it coming on this note of olfactory memory, this ode to smells is about to come to an end.